Welcome to the Deep Dive. Today we're tackling, well, probably the most urgent tech problem right now, AI reliability. I mean, we've all seen the incredible, sometimes really jaw-dropping progress with large language models.
Oh, absolutely. The capabilities are stunning.
But that success, it's built almost entirely on one particular engineering philosophy,
Yeah.
just brute force.
It's true, yeah. The current AI generation is basically a giant statistical machine. We
Mhm.
just throw petabytes of data, massive amounts of compute power at these systems, and train them to spot patterns, predict the most likely next word. It works, it's effective up to a point, but it's not exactly elegant and definitely not sustainable long term.
And the key thing is it leads directly to that issue you hear about all the time.
Yeah.
Hallucinations. For you, the listener, if you're not familiar, a hallucination is when the AI generates information that sounds perfectly logical, totally authoritative, but it's actually completely made up. It's like a confidence trick.
Exactly that. The AI is just relying on statistical correlation, what looks most like the right answer based on this huge, messy training data set it has.
Which is full of human errors and biases.
Precisely. So if that data has flaws or noise or, human biases baked in, the AI learns to replicate those flaws, often with very high confidence.
Yeah.
And that just completely undermines reliability, especially in high-stakes fields.
So, okay, our mission for this deep dive is to explore the alternative path, maybe a more foundational, more elegant solution. What if AI could rely not just on statistical consensus from all that messy human data,
Right.
but on actual verifiable truth derived from foundational axioms like first principles? It's a big shift from asking what's the most common answer people give to asking what must logically be true.
It really is the difference between prediction and proof. I mean, look at mathematics. Accuracy there is basically a solved problem, right? Because every single calculation is held accountable to these rigorous foundational axioms.
Like 1 + 1 = 2.
Exactly. 1 + 1 = 2, and there's zero statistical chance it equals 3. That certainty, that absolute certainty, is built into the mathematical system through logical consistency. And we want to bring that same kind of provability to AI tasks that deal with knowledge.
Okay, so let's unpack that core divergence then. If this axioms-based approach works so perfectly, guarantees consistency in math, why hasn't that sort of simple elegance been widely applied yet to linguistic AI, language problems? Why are we still kind of stuck in this statistical sandbox?
Well, we do have to acknowledge that language and just human experience generally is much, much more complex than simple arithmetic. That's fair.
Sure.
Some questions are just inherently probabilistic or kind of squishy, you might say, like, will I be happier buying a house in the city versus the suburbs?
Right, it's possible to answer definitively.
Exactly. It depends on billions of constantly shifting variables, personal preferences. AI can really only offer an educated guess there, a probabilistic one.
Yeah, okay, that makes sense. We shouldn't expect AI to, axiomatically solve human happiness. That feels like a stretch.
Definitely not. But think about the vast majority of tasks needed in fields where reliability is absolutely non-negotiable. Finance, medical diagnostics, legal reasoning.
High-stakes stuff.
Exactly. Those areas mostly deal with facts, establish chains of cause and effect, verifiable data points. They require consistency. And in those areas, we absolutely need a system where logical consistency can, verify facts, spot basic reasoning errors, and let the system adapt its knowledge without creating contradictions.
Okay, so this is where it gets really interesting then. The solution being looked at isn't purely one or the other, it's a hybrid. We're seeing movement towards systems that combine the pattern-spotting power of neural networks, the stuff that makes ChatGPT sound so fluid, with the structured reasoning of symbolic logic. And this merger, it's often called neuro-symbolic AI.
Yeah, that's the term. It really tries to connect the best of both worlds. You get the neural network handling the raw language, figuring out potential relationships.
The messy stuff.
The messy stuff, exactly. And then the symbolic part acts like a really strict logical filter over that. But, connecting this to the bigger picture, we should probably ask why those early attempts at symbolic AI trying to encode knowledge with rules back in the, 80s, why they stalled out.
Good point. Because if structured reasoning is so powerful, why didn't it take off then?
Well, those early systems, they were quite brittle, weren't they?
Yeah, I remember reading that. They needed humans to manually type in every single rule, every fact.
Exactly. They were great at complex problem solving, like theorem proving, but only within the very closed world of the rules humans gave them. They couldn't generalize well, and they certainly couldn't handle the sheer messiness of natural language or the huge volume of data we have now.
Right.
What makes neurosymbolic AI different now is that the neural network part handles the messiness, the generalization from data, and the symbolic component isn't there to store all the world's facts, but rather to enforce the fundamental rules of reasoning itself. It's really about teaching the AI the basic rules of reality.
So we're literally talking about teaching AI what we humans kind of implicitly understand about how the world is structured, these conceptual axioms that define how we reason and perceive things.
We are, yes. The real power lies in integrating these first principles, these absolute building blocks for verifiable truth, and then formalizing them so the AI can actually use them as a kind of verification layer. I think it's time we maybe dive into that blueprint.
Absolutely. Let's get into the foundational framework. If the goal is to define logical consistency so a machine can use it, where do we even start? What are these core axioms?
Okay, we can probably group these essential axioms into maybe three categories.
Okay.
Let's start with the absolute bedrock of all logic. The first three basically define how something relates to itself and its truth value.
Right.
First, you have the law of identity. A thing is itself. Simple as that. A is A.
A is A.
Second, the law of non-contradiction. A statement can't be both true and false at the same time in the same way. So A cannot be both A and not A.
Makes sense.
And third, the law of excluded middle. For any proposition, any statement, it's either true or it's false. There's no third option, no middle ground.
Okay, wait. Those three right there seem to directly address the core issue of hallucinations we talked about.
They do.
Because if a model has to follow non-contradiction, it can't tell me the sky is green and also tell me the sky is blue in the same breath.
Precisely. It forces a choice based on consistency. Now let's move to the next group, which is more about defining reality and causation. These are the principles that help ensure the AI's generated knowledge is grounded in a consistent reality, not just, plausible-sounding fabrication.
Okay, grounding it.
So fourth, we have the principle of sufficient reason. Basically, for every fact or truth, there has to be a sufficient reason why it is the way it is, and not some other way.
Huh. That one sounds really powerful. If the AI states a fact, it needs to be able to trace why it's stating it. Prevents just making stuff up arbitrarily.
Absolutely. It demands a basis. Fifth is the axiom of causality. Every effect has a cause, and that cause comes before it in time.
Standard cause and effect.
Right. Sixth, the principle of uniformity. This means the basic laws governing the universe are consistent across time and space. What happened yesterday under certain conditions will, happen again tomorrow under the same conditions.
Like gravity working the same way today as it did yesterday.
Exactly. And seventh, the axiom of existence. For something to have properties or be described, well, it has to exist in some form first. You can't describe the properties of something that doesn't exist.
I can really see how enforcing these rules fundamentally shifts the system. It goes from just being a pattern generator to more of a reasoning engine. The AI can't just invent events or claim causes that contradict each other.
It forces provability, or at least traceability. Okay, finally, we have a couple of relational principles axioms that define how things interact logically.
Right.
Eighth is the law of transitivity. Pretty intuitive. If A is related to B in a certain way and B is related to C in that same way, then A is also related to C in that way.
Like if A is bigger than B and B is bigger than C, then A is bigger than C.
Perfect example. Ninth is the principle of equivalence. If two things are identical in absolutely all their properties, then they are, in fact, the same thing.
Okay, 8 and 9 feel like really intuitive logical tools. We use those constantly without thinking. But then there's the 10th one you often see listed, usually in set theory, the axiom of choice.
Ah, yes.
It says, for any collection of non-empty sets, there's a function that can pick one element from each set. That sounds super abstract. How is that relevant to making language AI more reliable?
That is a great question, actually, because it does sound very mathematical. But it touches on the necessity of being able to make consistent decisions or selections, even when dealing with massive amounts of complex data. Think about it in practical AI terms, especially for knowledge extraction or reasoning. Let's say the AI is analyzing multiple complex medical reports to form a diagnosis. It needs to select the key relevant facts from each report. The axiom of choice, in a conceptual sense here, ensures the system can perform that selection process consistently and reliably across all the sets of information, which guarantees the logical completeness of the final inference it makes. It's about the ability to make necessary choices within the data space coherently.
Fascinating. So it underpins the ability to reliably pull together information from different sources. Right, so that's the foundation, roughly 10 conceptual axioms we humans use, often unconsciously. Now, let's imagine this paradigm shift in action. How does this mechanism actually work inside the AI? Instead of just looking for consensus in data, the AI is subjecting every query, every piece of information to rigorous analysis using these principles. How do you actually teach a big transformer model these absolute truths?
Right, so we use specific methods, often falling under the umbrella of axiomatic training. This isn't just about feeding the model more facts, it's about exposing the transformer to repeated, highly structured examples of these logical rules in action.
So like drills, logical drills.
Kind of, yeah. It's about teaching it how to reason correctly. For instance, you might present it with lots of causal reasoning tasks, and then you subject its output to a filter, maybe a symbolic layer, that strictly enforces, say, the law of non-contradiction. The system learns, through trial and error, guided by this enforcement, to reject answers that might be statistically plausible based on its training data, but are logically impossible according to the axioms.
Okay. So the neural network does its usual thing, generates probabilistic candidates, maybe several possible answers,
Exactly.
and then this symbolic layer, armed with those 10 axioms we discussed, acts as a filter or a validator.
Precisely. The symbolic engine acts almost like a referee. It checks if the semantic output from the neural network violates any of the fundamental rules of reality or logic that we've encoded as axioms. And we've already seen this approach work. It successfully taught transformer models better causal reasoning, which leads to much better generalization to new situations, and importantly, a significant drop in inference errors.
Just that improvement in inference errors alone sounds like a massive win, especially for those high-stakes fields like medicine or finance.
Yeah.
What other specific benefits are researchers seeing in these neurosymbolic systems compared to the purely statistical models we mostly use now?
Oh, the benefits are quite systemic. First, as you might expect, you get enhanced logical reasoning. This makes the models inherently more robust, especially when they encounter new information or maybe information that contradicts something they saw in their training data.
They don't get thrown off as easily.
Exactly. Second, and this is a big one, they help solve one of the most frustrating problems with current AI. They show reduced catastrophic forgetting.
Catastrophic forgetting. Yeah, that sounds pretty bad. What exactly is that?
It really is. Imagine a purely neural network, kind of like a complex web of connections. When you train it on new information, update one part of its knowledge, it can sometimes inadvertently damage or even completely wipe out unrelated foundational knowledge it learned previously.
Like learning about birds makes it forget about fish.
Metaphorically, yes, it's a huge problem for systems that need to learn continuously. But symbolic rules, the axioms, help prevent this erosion. If the system knows axiomatically that A is A, it simply cannot forget that core truth when it learns something new about B, because that rule, A is A, is independent of the new data about B. It's fundamental for any system that needs to learn continuously over long periods in the real world.
Wow, okay. I can definitely see how that capability makes them much more suitable for real-world deployment where things are always changing. So, if we humans manage to be reasonably accurate, even with limited data, partly because we have these innate logical filters, what else does integrating this symbolic reasoning give the AI?
Well, another big advantage is it boosts interpretability. We can often literally track the logical steps the AI took to reach a conclusion by looking at how it applied the symbolic rules. That's crucial in fields like medicine or finance, where you need to understand why the AI made a recommendation.
The black box problem gets less black.
Exactly. But perhaps the most significant capability it enables is allowing the AI to handle non-monotonic reasoning.
Non-monotonic reasoning. Okay, that sounds like another technical term we need to unpack. Can you define that for us?
Sure. So monotonic logic means that once you establish a conclusion is true, that conclusion can never be retracted or changed, no matter what new evidence comes along. Think 1 + 1, 2. That's never changing.
Right, fixed.
Fixed. Which is fine for math, but it's terrible for reasoning about the real world, which is constantly changing and revealing new information. Non-monotonic reasoning, on the other hand, allows the AI to revise its conclusions gracefully when it gets new evidence without having to throw everything out and retrain on the entire dataset from scratch.
Ah, okay. So if the AI learns, say, all swans are white based on its initial data.
Right.
And then later it encounters a black swan. A non-monotonic system can handle that.
Yes. Instead of crashing or having a contradiction, it can revise its belief to something more nuanced, like swans are usually white, but black swans exist. It adapts its knowledge based on new facts. It's the difference between rigid memorization and sophisticated flexible learning that can handle exceptions and updates.
That really feels like a hallmark of actual intelligence, doesn't it? That ability to gracefully adjust what you believe without discarding everything you knew before. Okay, so if we're already having success integrating the axioms we currently know about,
Yeah.
where does this research go next? What's the frontier here?
Well, this really raises the ultimate potential of this entire field. We're starting to talk about a future where an AI may be an advanced system specifically designed for scientific discovery, perhaps like those Sakana AI scientist-type systems mentioned in some research, is trained not just to use the axioms we give it, but to actually discover new linguistic or conceptual axioms entirely on its own.
Whoa. Okay, the implications of that are staggering. An AI verifying and maybe even expanding the fundamental rules of how we understand reality.
Think about it. It could mean that needing a vast corpus of human-generated knowledge becomes far less necessary for certain tasks. Why? Because the system could potentially derive and prove truths from core principles rather than just pattern-matching historical data created by humans.
It shifts the source of truth, in a way, away from just statistical consensus of what humans have written towards verifiable, perhaps even self-derived principles.
Exactly. And crucially, think about this. The models could potentially avoid being corrupted by faulty human reasoning, inherent biases, and simple inaccuracies that are inevitably scattered throughout those massive public data sets we currently use.
Right. If the AI can test incoming information against its own robust set of axiomatic truths, it could automatically filter out the noise, the contradictions, the biases.
Precisely. So augmenting the standard data and compute approach, which is powerful but flawed, with rigorous linguistic axiom testing, it really could revolutionize every field that requires precision and reliability. It's about turning those probabilistic guesses, which are useful but sometimes wrong, into absolutely. We're seeing a potentially pivotal move here beyond just training AI on what humans generally agree on and towards integrating these foundational axioms to actively enforce verifiable, provable consistency. That seems essential if we want to elevate AI's reliability, moving it from just being a powerful guesser to becoming a truly trusted reasoning partner, especially in those critical high-stakes areas.
Okay, and to wrap up, here's a final provocative thought for you, our listener, to consider. If AI can eventually be trained, not just to use, but to discover fundamental truths, perhaps new linguistic or conceptual axioms that humans aren't even consciously aware of yet, what currently accepted facts or beliefs might suddenly be exposed as logically unsound, and how profoundly might that change the very foundations of human knowledge? Maybe think about what other fields, perhaps even something like sociology or historical analysis, might be ripe for this kind of axiomatic revolution down the line.